Good morning, students. So let us continue with the same chapter. So the question reads: a student takes a rectangular piece of paper 30 centimeter long and 21 centimeter wide. Find the area of the biggest circle that can be cut out from the paper. Also find the area of the paper left after cutting out the circle. So if you can see here, this will be the piece of paper. So length is 30 centimeter and breadth is 21 centimeter. In this case, we can only draw a circle whose diameter will be equal to its breadth, the largest circle that we can draw. Because if we draw a circle that is whose diameter is equal to the length of the rectangle, then it will go outside of the rectangle, which is not possible to cut out. So I hope you are clear. So we'll start by saying let ABC be the rectangular piece of paper. The largest circle we can cut would be that with the diameter equal to the breadth of the rectangle, that is 21 centimeter. So its radius equals to 21 by 2 equals to 10.5 centimeter. Its area equals to pi r square, that is equal to 22 by 7 into 10.5 into 10.5, which happens to be 346.5 centimeters square. Okay, so we have found the area of the largest circle. So the question has also asked us to find the remaining area. So remaining area would be, just take out the area of the rectangle. From there, just remove the area of the circle. So that's what we are trying to do. So I'll write remaining area equals to area of the rectangle minus area of the circle, which will turn out to be 30 into 21, because length into breadth, minus 346.5. So which turns out to be 630 minus 346.5, that is 283.5 centimeters square. Yes. So let us go ahead with the next problem. A rectangle with one side 4 centimeter is inscribed in a circle of radius 2.5 centimeter. Find the area of the triangle. I think it should be find the area of the rectangle. Sorry, it's find the area of rectangle. Okay. So let us start. So this is a rectangle of side 4 centimeter inscribed in a circle. Okay, so radius is 2.5 centimeter. Yes. So let us see how we can solve this problem. So here BC equals to 5 centimeter. So why BC is 5 centimeter? BC is 5 centimeter because if you see properly, this is the diameter of the circle. And diameter of the circle, radius has been given as 2.5 centimeters. So the diameter will be twice of it, that is 5 centimeter. And this also happens to be the diagonal of the rectangle. Yes. So I'm writing here BC equals to 5 centimeter, which is the diagonal of the rectangle. We know diagonal equals to 5. So or under root L square plus B square equals to 5. So or 4 square plus B square equals to 5 square. So or 16 plus B square equals to 25, or B square equals to 25 minus 16. Therefore B equals to under root 9, that is 3 centimeter. So area of the rectangle equals to length into breadth, that is 4 into 3 equals to 12 centimeter square. So what we have done is we have just used the diagonal, which is also the diameter, and from there find out the breadth, and finally we get the answer as 12 centimeters square. I hope you are clear. In the figure given below, calculate the area of the shaded region correct to two decimal places. So take pi equals to 3.142. I have told you, if it is mentioned that we have to take the value of pi as 3.142, you have to take it accordingly. Okay, so let us start solving the problem. So length is 12 centimeter and breadth is 5 centimeter. So area of the rectangle equals to 12 into 5, that is 60 centimeters square. Again, I'll use the concept of diagonal here, because we know the diagonal of a rectangle inside a circle will become the diameter of that circle. So also the diagonal of the rectangle will be the diameter of the circle. So diagonal equals to, after doing all these things, I found it as 13 centimeter. So radius of the circle equals to 13 by 2, that is 6.5 centimeter. So therefore area of the circle will become pi r square, that is 3.142, question has given us, into 6.5 into 6.5, that is 132.75 centimeters square. So area of the shaded portion is very logical. So we have to subtract the area of rectangle from the area of the circle. So we'll get 132.75 minus 60, that is 72.75 centimeters square. I hope you are clear with this. So let us go ahead to the next problem that I have. In the figure given below, ABC is an isosceles right-angled triangle with angle ABC equals to 90 degree. A semicircle is drawn with AC as diameter. If AB equals to BC equals to 7 centimeter, we are discussing about isosceles triangle. So two sides will be equal. So find the area of the shaded region. So let us draw the diagram. So diagram will be something like this. So AC will be the hypotenuse, but at the same time it will also be the diameter of the semicircle. So I'm calculating area of the triangle ABC. So area of the triangle ABC equals to half into base into height. So half into base is BC and height is AB. So we have been given their value. So I'm writing 49 by 2. That is 24.5 centimeters square. But we need to find the area of the semicircle also as well. Yes. So for that we require radius. So radius can be found out using diameter. Diameter in this case is hypotenuse, and they have told that it is a right angle triangle. So let us make use of Pythagoras theorem. So in triangle ABC, by Pythagoras theorem, AC square equals to AB square plus BC square. So I'm just trying to find the value of AC. So AC will give me 7 under root 2 centimeter. This will also be the diameter of the semicircle. So radius will be diameter divided by 2, that is 7 under root 2 divided by 2. So then area equals to pi r square by 2 equals to, I'm just putting the value. So finally you will get 77 by 2. So area of the shaded region equals to area of the semicircle minus area of the triangle. 77 by 2 minus 24.5, that is 38.5 minus 24.5, that happens to be 14 centimeters square. I hope this is clear. So let's go to the next problem. A circular field has perimeter 660 meter. A plot in the shape of a square having its vertices on the circumference is marked in the field. Calculate the area of the square field. So this will be the diagram that I am going to have. Okay, so let's start. So let the radius of the circle, we don't know, so let it be r meter. So given perimeter equals to 660 meter, using this I'll find the value of r as 105 meter. You can just pause the video and note it down. AC is the diameter of the circle and also the diagonal of the square. Yes, so AC equals to 2 into 105 because it is diameter and radius has been given as 105, so it will be twice of the radius, that is 210 meter. But it is also the diagonal, so I'm going to keep diagonal equals to 210 meter, and we know the formula for the diagonal of a square, and it's nothing but root 2 into side equals to 210. So therefore side equals to 210 divided by root 2 centimeter. We need to calculate the area of the square, right? So area of the square equals to side square, so that is 210 by root 2 square. So doing all these calculations, you will get 22050 meters square. Yes, so this is how we calculate the area of the square. So let's go to the next problem that I have. In the adjoining figure, ABCD is a square. Find the ratio between the circumference of the circumcircle and the incircle, the areas of the circumcircle and the incircle. Sorry, that's in that case I have written circumcircle income circle. It's incircle only. Okay, pardon me for that. So let's try to understand what is incircle. If you see, there is a square inside, right? So if I draw a circle inside a square, it will become an incircle. And if I draw a circle outside the circle but its vertices are being touched by the circumference of the circle, then I have circumcircle. So here I am having incircle and circumcircle. So let us try to calculate its ratios. So the diameter of the circumcircle is the diagonal of the square. If you see, its diameter of this outer circle will be the diagonal of the square, and also the length, the diameter of the inner circle will be the side of the square. Okay, I have drawn it with the red ink, you can notice it properly. So let the side of the square be a, then diagonal equals to root 2a. Also diameter of circle equals to root 2a. So radius equals to root 2 by root 2 of a by 2. So circumference, in that case circumference of some circumcircle will be 2 pi r. So I found it as root 2a pi. So circumference of incircle will be 2 pi r. So that is 2 pi. Remember, diameter for incircle is a, because I have told you it will be the side we have kept it as a. So radius for incircle will be a by 2. So I come down here, I'll write 2 pi a by 2 into a pi. So remember, we are calculating its ratio. So ratio is nothing but comparison. So ratio equals to root 2 a pi is to a pi. So I can cancel. I got it as root 2 is to 1. Yes. So let's try to calculate area of circumcircle. Area of circumcircle will be nothing but pi a square, pi r square. So r we have got it as root 2 a by 2. So doing all these things, I'll get pi a square by 2 Similarly, area of in circle equals to pi r square equals to pi into a by 2 whole square. So pi square by 4. After doing these calculations, I'll get ratio equals to 1 is to 1 is 1 by 1 is to 1 by 2. So when you just it's like cross multiplication only. You can do 2 is to 1. Yes. So remember two things in this question. So first thing is circumcircle's diameter will be the diagonal of this square, and this diameter of the incircle will be the side of this square. I hope you are clear. So with this we have finished that problem as well. So let us discuss this problem, question number 27. The figure given below shows a running track surrounding a grassed enclosure PQRSTU. Yes, the enclosure consisting of rectangle PQST with a semicircular region at each end. So calculate the area of the grassed enclosure. And it's very simple. So we'll just try to calculate the area of the rectangle, that is ABED or PQRS, as has been suggested by the question, and we'll just calculate the area of the semicircles at the end and just add it up. We'll get the answer. Yes. So area of the rectangle equals to area of the rectangle PQST is nothing but length into breadth. Length has been given as 200, breadth has been given as 70. So you'll get 14,000 meters square. So area of two semicircles pi r square by 2 plus pi r square by 2. I can write it as pi r square. So pi into 35 into 35, you'll get 3850. So area of the grass enclosure will be 14000 plus 3850, which happens to be 17,850 meters square. So this is also very straightforward. I hope you are clear with this. So let's go to the next problem. In the figure given below, two circles with center A and B touch each other at the point C. If AC equals to 8 centimeter and AB equals to 3 centimeter, find the area of the shaded region. If you see in this diagram, this is not a concentric circles. Concentric circles are those circles having the same center. But in this case, the center is B and A, right? So AC equals to 8 centimeter, AB equals to 3 centimeter. Yes. So I'll write AC equals to 8 centimeter and AB equals to 3 centimeter. Then can I write BC equals to AC minus AB? BC equals to AC minus AB. I can write it, right? So it will be 8 minus 3 centimeter. Now you might be asking why I am finding BC. If you see, BC is the radius of the smaller circle. So using that, I'll just calculate its area. So area of the smaller circle equals to pi r square. After doing all these calculations, you will get 550 by 7 square centimeter. Similarly, A is the center of this bigger circle, so its radius will be AC. So AC, so area of the bigger circle equals to pi r square, that is pi into AC square, equals to pi into h square, that is 22 by 7 into 64, that is 14087 square centimeter. Kindly write square centimeter over there. So area of the shaded region will be area of the bigger circle minus area of the smaller circle. Yes. So after this, I'll write 1408 minus 1408 by 7 minus 550 by 7 equals to 858 by 7, that is 122.57 centimeter square. Okay, so let us discuss the last problem that I have. The quadrants shown in the figure given below are each of radius 7 centimeter. Calculate the area of the shaded portion. So what my logic out here will be, so 7 centimeter, I'm just going to form an imaginary square. It's not there, but I'm just finding it to be, making it to be imaginary with dotted lines. So each quadrant is of radius 7 centimeter. So area of 4 quadrants will be 4 into pi r square by 4, that is pi r square only. So I'll write 22 by 7 into 7 into 7, that is 154 square centimeter. So area of the square will be 14 square. How I got side to be 14 is, if you see here, 7 and 7 I need to add to make the bigger square. Yes, so it will be 14 square. So it will be 196 square centimeter. So area of the shaded portion equals to 196 minus 154, that is 42 square centimeter. So from the bigger square, I'm just removing the area of the quadrants, each quadrant. So I'll get the answer. Yes, I hope this is clear. So if you have any doubt, you can ask me through WhatsApp or we can discuss it in the next class as well. I take your leave. Thank you.